Good afternoon, YouTube. I'm Chucky2009, and today we're going to be talking about the various common welding processes. I remember when I first started getting into welding, not so much as a career, but just as a hobby, and pretty much mainly because I thought it was cool. You know, reading around on the forums and reading what other people had to say, you'll hear a lot about all sorts of different common welding processes, but it can be kind of hard to figure out what exactly is going to serve you best for whatever it is that you're doing. And so I figured I'd go ahead and put together a video talking about some of the main types of welding processes and, well, of course, what might be best for you based on what exactly it is you're trying to do. Alright, well, I guess the first process we're going to talk about is MIG welding. Now with MIG, you've got this machine here is a machine that only does MIG welding. It's a single process machine, but the way it works is you've got your wire which comes on a spool. This one's only about 30, no wait, this is 23 thousandths. This is some real narrow stuff. This is 23 thousandths MIG wire. The common sizes are 23 thousandths, 30 thousandths, 35 thousandths, and 45 thousandths, and of course there's some bigger than that. But you got your wire on a spool, and then there's a mechanical drive system that feeds the wire from the spool into the liner, which is that silver thing just to the that's sticking out of that brass nut there, it looks like. And the liner runs through your MIG gun, and then out the other end of your MIG gun, you've got the tip of the wire there. Let's wait for this camera to focus. Yeah, you can see the tip of the wire sticking out. That's that little ball. It gets a little bit melted when you, you know, go to break the arc sometimes. But that, in a nutshell, is MIG welding. It's a gas-shielded process, which is nice because there's no slag to chip, but you're also going to need some gas to go with it. This is 80% argon, 20% CO2. What's a lot more common is 75% argon and 25% CO2. It's commonly called C25 or 75-25 mixed gas. I've never really heard of 80-20, but I mean, this is pretty much all my welding supply had last time I went to exchange a cylinder. So I got 80-20. Works pretty much the same. Alright, so what are some of the advantages and disadvantages of MIG welding? Well, first off, it's fast. It is one of the faster common processes. You put down a lot of metal very quickly, and you do this because, you know, you obviously have a faster travel speed down the joint than some other processes, but also because since it's a gas shielded process, there's no slag to chip, and thus your post-weld cleanup is minimal, just a little bit of spatter. Another advantage to MIG welding is that it's pretty much like a hot glue gun for metal. It is one of the easiest, if not the easiest process to run, but don't take that too far. True story, when I was in welding school, one of my classmates, when we first started MIG welding, he's like, "Oh, MIG welding's the easiest thing ever. It practically welds itself." And then a little bit of time passed, and he actually failed his first MIG weld test. And long story short, we still make fun of him to this day. So there's that. Don't let anyone tell you it's the easiest, most mind-numbing thing ever. Don't get me wrong, it is easy, but it's not that easy. And the trick is, as easy as it is to run, it's very difficult to set. Then you have to set your wire feed up here and your voltage, which is a little bit more difficult. I mean, you have to get these two both set to the right point, whereas with a stick welder you just have one thing. If it's too cold, you turn the dial this way. But overall, it's really not that bad. I mean, if you're willing to do a little bit of homework and do a little bit of research and then just go out there and practice, it's not that hard to learn how to set up a MIG welder. Another advantage to MIG, specifically short circuit MIG, which is what we're going to be talking about. You know, I'll just take a second and talk a little bit about spray arc. There's two common forms of MIG welding. There's short circuit MIG and there's spray arc. With short circuit, which is what each of these machines that I just showed y'all do, you have the tip of the wire that basically jabs itself into the base metal and creates a short circuit. Like, you know, when you hear that bacon frying sound of a properly tuned MIG weld, that's not actually delicious, yummy, dead animal simmering. That's actually a bunch of little bits of wire meticulously repetitively jabbing into the base metal. And that's also why when you first start MIG welding, it's kind of sputtery and then it smooths out. That's because once you get going, you've been welding for a second, then your puddle forms, and then the wire's jabbing into a comparatively soft molten puddle versus, you know, rock hard steel base metal. But spray arc is a little bit different because instead of short-circuiting the wire against what you're welding, it melts off just after the tip and it forms into a little glob and it goes flying down towards your base metal. And although it doesn't sound like a very big difference, spray arc is incredibly hot. It is very powerful, and it's not something I like to use on anything less than 1/4 inch. I mean, 3/16 is kind of pushing it. But regular short circuit MIG is something that I like to use on pretty much any minimal thickness. You can go all the way down to auto body with the 23 thousandths wire with thin diameter wire, and you can go all the way up to 1/4 inch, maybe 5/16. 3/8 is pushing it, but if you have a machine big enough, you can definitely do 3/8 in short circuit MIG, but anything more than that and you'll want to get into spray arc or another process, or at least do multiple passes of short circuit. But what are some of the disadvantages of MIG welding, you ask? Well, because it's gas shielded, it's not really the best to use outside. I've MIG welded outdoors before, and if there's any kind of a breeze and your shielding gas disappears and you end up with porosity, but you can get away with it. I mean, I obviously got it to work. Sometimes if there's absolutely no wind whatsoever, you can just crank up your shielding gas and sort of compensate for it. But MIG is definitely not the best process to use outdoors. Also, short circuit is something that's kind of known for being a cold process, so to speak. Not saying you can't get a good weld with short circuit MIG, you definitely can, but you can also create what you can think of as a deceiving weld. It looks good, it looks like it's tied in, it looks like it has good fusion, maybe some penetration, but it really isn't. It's really just sitting on top of the material. And especially with smaller 110 machines or running downhill on thicker steel, this is a problem that short circuit MIG is more or less known for. It's not that it's, you know, impossible to get a good weld with it, like I mentioned, but, you know, it doesn't really have behind it that stick welding or Flux Core or even TIG does. So that's something you're going to want to keep in mind. And also, there's a lot to go wrong. Whereas with some processes, basically just stick, your welder is a power source. I mean, like I just showed y'all, you have this dial here and you have 2 wires. This is pretty much all there is to a stick welder. But with a MIG machine, not only do you have all that, you have moving parts. You have this wire drive system, and you have the addition of a gas solenoid and a regulator and a tank and some other stuff. So there's a lot that can go wrong with MIG. If you buy a machine new, you shouldn't have to worry about this. And if you buy something used that hasn't been absolutely beaten to within an inch of its life, you'll probably be fine. But at the end of the day, it does require more complicated machinery than some other processes. And also, if I was going to get a new MIG machine, if I was just starting out welding, I would not want anything that's only 110. I mean, those things are limited. Let's say anything above about 1/8 inch is honestly kind of pushing it, in my experience at least. But I would want something that's dual voltage or 220 volt only, and about a minimum of 160 amps to 200 amps to get going. You know, you obviously can't really buy something that's too big, so to speak. Okay, I guess you can, but when you're working on something, if you get into some thicker steel, you can always have that extra power available. Like, I'll put it this way. You can always turn a big welder down, but when you're at the top of your little welder and you have something thick to weld, you can't really turn it up anymore. So to summarize, MIG is an excellent process for general fabrication. You can use it on a very wide range of materials, like I said, all the way from auto body to 1/4 inch, 3/8, depending on the machine. And it's a fast process, and it's pretty easy to run, among other things. Well, that YouTube is a little bit closer to what it's supposed to look like. It only gets so good if you're an incompetent hack like myself. But basically, as you can see, this doesn't really require much post-weld cleanup. There's a couple little pieces of spatter here and there. And if I was going to paint this, what I'd probably do is just take what I like to do is just to take a wire wheel on an angle grinder and just go over everything. That'll launch those things clean off of there. Or if I just wire brushed it manually, maybe used a slag hammer just to whack off the BBs. Post-weld cleanup, minimal at most. That's a cool thing about MIG welding. It's a very clean process. So, alright. Well, MIG welding. Yeehaw! Let's talk about Flux Core next. Alright, so What's the difference between Flux Core and MIG? Well, with MIG welding you have your wire obviously, and it is solid wire. It might be solid steel wire, it might be solid aluminum or solid stainless wire, but it's solid wire. There's nothing on the inside of that wire except for more wire. If that makes sense. But with Flux Core, the wire is hollow and it's filled with a powder called flux, which is very similar to what you find on a stick electrode. And what this does is it burns, the heat of the arc burns this material, and it creates a thick layer of smoke which shields your weld puddle from the atmosphere as it solidifies. With MIG we have that shielding gas that I showed y'all to protect your weld puddle. With Flux Core you have this burning material that burns and shields the weld puddle. So what are some of the advantages and the disadvantages of self-shielded Flux Core? We'll talk about gas shielded in a minute. Don't be like, what is he talking about yet? Well, it's a short list to be honest. Self-shielded Flux Core wire is pretty fast and you can use it outdoors. Yeah, that's literally all I have on my cheat sheet. There's not that much it's good to say about self-shielded Flux Core, and the reason for that is because it is a very dirty process. I'm not talking about smoke as in you throw a few leaves on your campfire. I'm talking about smoke as in you take an old box truck with some like 30-year-old, completely worn out, beaten and abused diesel engine that belches smoke, and you fill up the back of the truck with leaves and like some old tires and whatnot, and then you light that on fire with the engine running. That is how smoky self-shielded Flux Core wire is. It is by far the smokiest welding I've ever done in my entire life. There's usually a lot of spatter. It's just kind of nasty, to be honest. I don't particularly care for it, and there's a reason why most people with MIG welders choose to use the MIG process with them. We might as well talk about that. One of the advantages of Flux Core wire is that you can run it off of a MIG machine. You can't always run MIG off a Flux Core machine, but you can run Flux Core off pretty much any MIG machine. The reason for that is because MIG obviously requires the gas, whereas Flux Core only requires the wire feeding mechanism. So that's something to keep in mind. And two other things I'll add in is the only time that self-shielded Flux Core wire would be my process of choice is if I only had a MIG machine and I couldn't use shielding gas. Maybe I didn't have shielding gas. I actually did that here in the shop once. I ran out of shielding gas, so I burned some Flux Core wire. Or if you're welding outside, if you want a MIG machine and you want the awesomeness of MIG welding for your inside projects, but sometimes you might have to drag your awesome welder out into the yard or into the field to weld something and you're worried about your shielding gas blown away, self-shielded Flux Core might be something for you to think about. Also, there's a number of very cheap machines on the market that are Flux Core only machines, and sometimes the manufacturers will try to brag about their awesome gasless wire that their machines can run, and they try to make it sound like it's sort of a convenience. It's more desirable than MIG because there's no gas, when in reality they only make those machines like that so that they can save like $2 a machine by not putting a gas solenoid in it. Overall, those are bottom of the barrel machines. The quality is questionable at best. I don't have a lot of experience with these, you know, bottom dollar machines, so to speak, but I've heard a lot of horror stories about them. And if you have the money to spend, I highly recommend that you get an actual MIG machine. If you like running self-shielded Flux Core wire, you can still do that just as well or better because it'll probably be a better built machine. And you can, you know, run a whole nother process. You can run MIG. So, alright, those are some of the facts about self-shielded Flux Core wire. And oh yeah, another thing, it burns hotter than MIG. You know, with short circuit MIG, like I mentioned, it's sort of referred to as a cold natured, there's just not all that much oomph behind the arc, so to speak, but with self-shielded Flux Core it runs quite a bit hotter, so it's not good on thin material. Definitely don't buy one of those machines I just talked about if you're going to weld like auto body thickness. That's a really bad time. I'm sure it can be done, but it's not MIG for thin stuff. However, if you have a MIG machine and the amperage is kind of borderline, maybe you're welding some thicker stuff and you want something that burns a little bit hotter and burns in there better, well, that might be another time to use gasless Flux Core wire. Most self-shielded Flux Core wire runs on electronegative, whereas most gas-shielded Flux Core wire and pretty much all MIG wire runs on electrode positive. And one last thing to throw in, there is a lot of spatter with self-shielded Flux Core. That mess right there that was almost perfectly clean before is from only 3 5-inch long welds. There's the 2 y'all watched me do, and then there's this one on top I did just to get that arc shot. So there's a lot of smoke and there's a lot of spatter, but like every welding process, self-shielded Flux Core does have its place. Now, although it's not really commonly referred to as a starter process, it's not something most people do, you know, for their first welder, I'm just going to talk for a minute. I'll just say that it's probably going to be like, I don't know. Anyway, we're going to discuss gas-shielded Flux Core welding. Now, I know what you're thinking. Gas-shielded, so it's like MIG, but Flux Core, so it's how does that work exactly? Why would anyone run gas with Flux Core wire? Well, because it's not like it's really a mix of the two. I mean, it obviously kind of is, but I don't think of it as a mix of the two. I think of it as a whole nother process. It's not like a variation of MIG where you have to chip the slag, or it's not like a variation of self-shielded where you run gas. Gas-shielded Flux Core doesn't really feel like any other Flux Core welding I've done or any other MIG welding I've done. The way I usually refer to this is there's 2 ways you can go 100 miles an hour. You can be in like a 20, 30-year-old windowless creeper van, right? It had windows, but like one of them had some plywood on it because it got broken in like 1997 and you never bothered to fix it. And it's all rusty and it's like, it's got the shag carpet. I don't think that was an 80s thing, but anyway, it's got the shag carpet. It's in there anyway, don't ask questions. And you've never had it above 60 miles an hour because it doesn't really like to go more than about 57 or so. You start to go down the hill and you've got your pedal to the floor and it's making noises you're pretty sure an engine's not supposed to make, and it smells like burning oil because it is burning oil. There's a big old cloud behind you and the whole van's shaking like this, and there's a full 30 degrees of play in your steering, but you're gonna get it over where you think the 100 mile an hour mark should be if the speedometer went up to 100 miles an hour. And you got a bunch of scrap metal in the back and it's pushing you down the hill, and it's terrifying but it's exhilarating at the same time, and the van starts shaking even more, and you creep past where you think 100 miles an hour is. Or you can be in some modern sports car and you just press the pedal in a downward direction and the speedometer goes and hey, there's 100 miles an hour. 100 miles an hour is not always 100 miles an hour. Flux Core welding is not always Flux Core welding. You know, it is, of course, but it's not. The thing about gas shielded is it's a really nice process. I greatly enjoy running it. It's something that a buddy of mine, Pete, aka Schneetiger77, does a lot of. And I don't really have that set up in any machines here, so I'm not really going to try it out. But I will play some generic gas shielded Flux Core footage from previous videos. Enjoy! So now that we got that out of the way, the thing about gas shielded Flux Core wire is you have some of the best properties of MIG and you have some of the best properties of Flux Core and stick. I'll say stick. And they're kind of intertwined together into a whole nother animal. It runs smooth, silky smooth, like spray arc MIG, not like gas shielded Flux or self shielded Flux Core, and it doesn't have the bacon frying sound of short circuit MIG. It's normally done in a spray transfer. Like I said, it runs very smooth and the puddle flows nicely. It's easy to use out of position, and it is hot. It is one of, if not the hottest common welding process there is. Basically, it's like if you use it on anything less than 3/16, you're probably going to have a bad time, you know. Don't get me wrong, I'm sure you can. I'm sure people do it every day. But when I run it, it's not something I like to use on less than 3/16 or 1/4 inch. It's commonly used for high deposition rate production type settings and very thick steel. That's the stuff they use to build ships and railroad cars and like big old truck bodies and things along those lines. But if all you weld is like 1/4 inch up and you're like, hey, where's he going with this? If all you weld is like from 1/4 inch on up and you got to get a lot of it done fast, gas shielded Flux Core might be the thing for you. But if you're looking to patch up some rust on your old car or your old creeper van that you somehow survived going 100-ish miles an hour in, or you know, for a lot of other things, it's not really the ideal homeowner's hobbyist process. Not many people do this in their garage. You can, but it's not all that common. So that's a little something about gas shielded Flux Core wire.